Hi everyone, this is the fourth lecture of the first week, and here we're going to cover the hypothesis testing. As we have mentioned before, in statistical inference, there are two different procedures, estimation and hypothesis testing, and we're covering the second part. There are four steps for hypothesis testing. The first step is to set up an alternative and null hypothesis. The second step is to calculate the test statistics. The third step is to use either the critical value method or the p-value method. And then the fourth step is based on these, make a decision. So let's go back to our empirical problem. We were interested in how the class size affects the test score. So the first step is to set up a null and an alternative hypothesis. Our null is that the class size doesn't matter. In other words, the average test score of small class districts and the average test score of large class districts are the same. The alternative is that they're different. So the average test score of small class district and average test score of large class districts are actually different. We can set it up as one-sided alternative, so we can have one bigger than the other, but in this case, we'll just have the two-sided alternative where we're setting up as not equal. The second step is to calculate test statistics. Test statistics is generally calculated by first calculating the sample estimator, subtracting the population parameter, and dividing these by standard error of a sample estimator. So why do we calculate test statistics? The standardization formula that was shown in the previous slide provides a test statistics. And what it does is that it converts our sample statistics from sampling distribution to the standardized distribution. So the problem is that there are millions of sampling distributions. So instead of knowing everything about every single one of the sampling distribution, we actually standardized the sampling distributions. So it's easy to calculate the critical values or p-value. So the formula for calculating test statistics for a difference in means test is given here. As you can see, basically we divide the point estimate that we calculated before by the standard error of this point estimate. The standard error of point estimate is calculated by square root of variance of small class size divided by the sample size of the small class district, and then adding the variance of large class districts divided by the sample size of large class districts. The variance for small and large class is given here. Okay, let's go through calculation of t statistics by hand. So here we have all the numbers that we need. So there's average test score for the small class size district. There's a standard deviation for the small class size district. And this is the sample size. So we have 238 small class size districts. We have the counterparts, so the sample, our average test score, the standard deviation, and the sample size for the large class districts. Plugging these numbers into the test statistics formula, here it's pretty simple. So you just plug in the average test score for small class districts and large class districts, which gives us the point estimate that we calculated before. and then we square root, and since we only have standard deviation here, you square them to get variance divided by the sample size that we get from the table. And once you calculate that, you get 4.05 as the test statistics. So step 3 is to find either the critical value or p-value. Here we're going to start off with the critical value method. The critical value method says that once you have the test statistics and you calculate the critical value, then if your test statistics is more extreme than the critical value, then you reject the null. This critical value can be different if you have a two-sided alternative or one-sided alternative. In our case, we have a two-sided alternative, so that's what we're going to work with. So how do you get the critical value? In order to get the critical value, you need to know the significance level and degrees of freedom. The significance level is a pre-specified probability of incorrectly rejecting the null when the null is true. We call this type 1 error, or alpha. The significance level of 5% is commonly used in practice. The degrees of freedom for differences in mean can be calculated using this formula, where you subtract 1 from each group's sample size. Here we have 418 as a degrees of freedom. Once you have the significance level and degrees of freedom, you can use the table that is often given in the back of the textbook to get the critical value. Here is a table for the distribution, and it doesn't go all the way up to 418 degrees of freedom. But basically, you see where degrees of freedom intersects with the significance level that you want, and that number is the critical value. I also have this link where they calculate the critical value more easily than looking at the table. There is a website that I have it linked here that also calculates the critical value for you if you put in the degrees of freedom and the significance level. Once you put in degrees of freedom of 418 and significance level of 0.05, this website spits out the critical value depending on whether it's a one-sided test or a two-tailed test. So the last step is to make your decision. So we basically have to either reject the null or don't reject the null based on the t-test. And when you reject the null hypothesis in favor of alternative hypothesis, you're saying that there is enough evidence to infer that the alternative is true. So in our case, we are concluding that there is a statistically significant difference in test scores between the small class districts and large class districts. When you do not reject the null, you're saying that there's not enough evidence to infer that the alternative is true. One thing to note is that when you don't reject the null, doesn't mean that the null is true. It just means that we just don't have enough evidence. Going back to the critical value method, we calculated our test statistics to be 4.05, and our critical value was 1.96. You can either get this from the table or the website that I linked. And since this t statistics is greater than our critical value, we reject the null hypothesis at the 5% significance level. So we're saying that the average test score of small STR is not equal to average test score of large STR. Let's talk briefly about the other method, the p-value method. So p-value is the amount of evidence in favor of the null hypothesis. So the smaller the p-value, the less evidence you have in favor of null hypothesis, and the more evidence you have in favor of alternative hypothesis. So if you have a small p-value, then you're more likely to reject your null. In most cases, we use a significance level of 5%. So if your p-value is smaller than 0.05, then we reject the null. So how do you calculate the p-value? Here, I linked the calculator online that calculates a p-value once you give the t-statistics and degrees of freedom. If you enter these into the website and give them the significance level, tell them which type of test it is, it gives you the p-value. Here we get the p-value of 0.000061, which is way less than 0.05, our significance level. So we reject the null in this case. In this course, we're going to use the computer software Stata. So you never have to calculate the p-value. It spits out the p-value for you, so you don't have to worry about that. Also, with Stata, it's easy to use a p-value method instead of a critical value method. Because with the critical value method, you need to know the critical value, whereas p-value method, you only need to know the significance level.